Sri Gurubhyo Namaha children, welcome to our online teaching academy Ekalaiva. Topic of this video is CBSE class 10 science and the name of the lesson is light, reflection and refraction. In our previous class we were discussing about the rules to draw ray diagrams, and obviously in this video we are going to draw the ray diagrams by using those 4 rules. Okay. So in this the topic of this particular video is image formation by a concave mirror, and as well as we are at the end of this video we are also going to discuss about the convex mirror. Now we will start with the concave mirror, and here is the tabular column which will states if where we should if the particular object in a position, in a particular position where the image supposed to be formed. Okay. And this tabular column you are supposed to memorize because of that, because by using this tabular column we can do the numericals. Okay. Yes. So now I am going to picturize this tabular column. So now the first position of the concave mirror. Okay. The first position of the concave mirror is we are going to keep the object at infinity. So if the object at infinity, and obviously we are going to have the parallel rays from the infinity. So you are supposed to remember the rule 1. Rule 1 states that if the ray parallel to the principal axis, after reflection it will pass through the focus. So let me draw a few rays. All those rays will pass through the focus. Arrow mark is very important because it shows the direction of the light. Okay. So a ray parallel to the principal axis, after reflection they will meet at a point, and that point we will call it as focus. So the position of the object is infinity and position of the image is focus. And what type of image we have got here is, it is real and inverted. At the introduction part I have discussed about the real image, difference between the real image and as well as the virtual image. Real image can be captured on the screen, okay, and real image always it will be inverted. And talking about the size of the image, it is very highly diminished and it is point sized. Okay. So when the object at infinity, the image formed at the focus, that size will be very diminished and it is real and inverted image. Okay. Now we will go with the next position. The next position of the object is beyond C. So I am going to keep the object here. Object we used to denote with the arrow mark. Okay. Let me use the rule 1. So ray parallel to the principal axis, after reflection will pass through the focus, and then we will use the rule 2. A ray passing through the focus after reflection will emerge out parallel to the principal axis. Where does the image form? The image will be formed where two reflected rays meets. Okay. So in this picture you can see this is the incident ray and this is also an incident ray, and these two are the reflected ray, and these two reflected rays are meeting here, and here is the image will be formed. And if you see the image obviously it is real and inverted, and the size of the image is diminished, okay, and it is real and inverted. I have told you the position of the object is beyond C and the position of the image is between C and F. Yes, so this is the second position of the object, and now we will move on to the third one. Now I am going to keep the object at C. So we are going to use two rules, rule 1 and as well as the rule 2. A ray parallel to the principal axis, after reflection they will pass through the focus, and the ray through the focus, after reflection they will emerged out parallel to the principal axis, and where they were meeting, actually I didn't draw properly so it is meeting somewhere else, but you can see in this picture the position of the object is at C. So when we keep the object at C and the image also will formed at C and the size will be same size and they are real and inverted. Yes. Now we will move on to the next one. Now the position of the object is between C and F. C and F. Rule 1, a ray parallel to the principal axis, after reflection passes through the focus, and the ray which is passed through the focus, after reflection they will emerged out parallel to the principal axis. So these two are meeting over here. So the image formed beyond C, and the size of the image is obviously it is enlarged. So position of the object is between C and F, and position of the image is beyond C. So you can see here, and it is enlarged. You can see the size of the object and as well as the size of the image. It is enlarged and obviously it is real and inverted. Yes. Now we will move to the next position. The next position is at F. A ray parallel to the principal axis so that it passes through the focus, and the next ray, this is rule 1 and we can use rule 4. Okay. A ray incidence obliquely will be reflected obliquely. Okay. And when the object is in focus, what happens? These two reflected rays will not meet as soon as, they will take a longer, which means they will meet at infinity. Okay. And the size of the image is highly enlarged and they are real and inverted. Yes. Now we will move on to the next one. Now I am going to keep the object in between the pole and the focus. So a ray parallel to the principal axis, after reflection passes through the focus, and next one which incidents obliquely. So what happened? These two rays also will not meet. So what we are supposed to do is, we can extend these reflected rays, they will meet at a point behind the mirror. Okay. So that one, there the image will be formed. So now the position of the object is between pole and the focus, and the image formed is behind the mirror, and it is enlarged. You can see the size over here, and they are virtual and erect. Yes. So these are the positions. Okay. Now let me tell you how to remember this one. When you take the object, you can see, I mean, here I have comprised all the position of the objects. Okay, so if you see now the image, the object is at infinity, and then it infinity, and then in this picture it came to beyond C, and then here is at C, and then between C and F, and at F, and between F and P. Okay, only these 6 are the position of the objects. Okay, so when you see the position of the object will move forward to the, what is that, mirror. Okay, but if you talk about the image, in the first case it forms at focus, and then it moved backward to between F and C, and then it came to C, and then beyond C, and then infinity, and then we will consider till here, because all these 5 cases the concave mirror produces real and inverted images. All the 5 positions the concave mirror will produce real and inverted image. And when you see the size of the image, when you take the first case, it was point sized, and then it is diminished, okay, and then same size, and then enlarged, and then highly enlarged. So it keeps on increased in the size. So as the object moves towards the concave mirror, the size of the image keeps on increased. Okay, yes, yes. And then in the last case alone is the exceptional case, because in this case the concave mirror produces virtual and erect image. So this one we can see it at, the image will be formed in the mirror itself. We know the difference between real image and as well as the virtual image. Real image can be captured on the screen, virtual image cannot be captured on the screen, they can be seen on the mirror. And real image always it will be inverted, that is upside down, but virtual image always it is upright, which means erect, they are always erect. Okay, so these are the positions of the images, and as well as position of the object, and as well as the images. Now we are going to discuss about the uses of concave mirror. Okay, so the very first use of a concave mirror is, they are used in the searchlights or torchlights, you can say it in any way. Okay, searchlights or otherwise torchlight. Okay, so what happens, this curved surface is nothing but the concave mirror, and if the concave mirror at the focus, if the bulb it is in the at focus, what happen, a ray, all the rays it will incidence on the concave mirror, and they will give a parallel beam of light, so that we will get a bright light. Okay, yes, so that is in case of searchlights. And they are also used in the headlights of the vehicles, not only the car, all the vehicles. Okay, and here also the same principle, you can see the bulb is kept at the focus, so that we are getting a parallel beam. We know that this is the position of the object is that we were read about the image formed by the concave mirror, and this is the 5th position. So when the object is at F, the image will form at infinity, so that we are getting a parallel beam of light. Okay, and the next usage is, this concave mirror is used as a shaving mirror or otherwise makeup mirror, you can say it in any way. Okay, so this is if we draw the ray diagram for this particular use, the object should be placed between the pole and the focus. So when the object is very near to the concave mirror, it will produce virtual and erect image, and also it is enlarged image. So this concave mirror has been used for the shaving mirror and as well as the makeup mirror. And next in the solar furnaces. So solar furnaces, the position of the object here is at infinity. So what is the object over here? sun is the object over here. So this concave surface will converge all the sun rays at a point. Okay, so that point we will call it as focus. So when it is in the focus, what happen if we keep the container over there, all the converged rays will meet at a point. So the light energy and as well as heat energy will be produced over there. Okay, yes, yes. And the last use is the dentist. So dentist also use the concave mirror in order to examine the patients. Okay, and here also the position of the object is between pole and the focus. Okay, between pole and the focus. So when the dentist keep the object, that is the teeth in between the pole and the focus, the enlarged image of that teeth can be observed on the concave mirror, so that he can have an idea about the patients. Okay, so that's all about this concave mirror. Now we will be switching on to the convex mirror. So convex mirror image formation is very simple. There are only, in case of concave mirror we have discussed about 6 different position of the objects. Now here it is very simple, because if the object is at infinity, what happened, the image will formed at the focus. Okay, and it is highly diminished point size, and it is virtual and erect. And from infinity to pole, wherever we keep the object, the image will be formed between pole and F behind the mirror, and it is always diminished and virtual and erect. Okay, now let us picturize this tabular column. This is the first case. So in the first case you can see a concave mirror. So concave mirror, the non-reflecting surface is inside the sphere. Okay, so outside is the reflecting surface. So object is at infinity, we are getting a parallel rays. So you know the first rule, if the ray is parallel to the principal axis, as it is a diverging mirror, they will get diverged. Okay, so when they are get diverged, they are appear to come from a point. So that is called focus. Okay, yes, yes. So first position, we are keeping the object at infinity. So image is formed at focus. The type nature of the image here is virtual and erect image, and it is highly diminished image, very point sized. Okay. Next position, the next position of the object is, I have told you already, from infinity to the pole, wherever we keep the object, the image is going to, we are going to obtain the image between the pole and the focus. Okay, so we can use the rules over here. So first rule has been used, a ray parallel to the principal axis, it get diverged, but it appear to come from the focus. Okay, and the next ray is through the, it is directed towards the center of curvature, so it takes back its own path. Okay, so these two reflected rays are meeting in a point, and here is the image formed. So image formed between pole and the focus, and if you see the size of the image, it is very diminished, and it is virtual and erect image. Okay, so what is the difference between, even concave mirror also produces virtual and erect image, and the convex mirror also produces virtual and erect image. But what is the difference? Convex mirror, it is always produces diminished image, but if you take the concave mirror will produce the enlarged image. Okay, so concave mirror also produces virtual image, but convex also will produces virtual image, but convex will always produce the diminished virtual image, concave will always produce the enlarged virtual images. So those two, these two are the difference between the virtual image formed by the concave mirror and as well as the convex mirror. And Now let us move on to the uses of convex mirror. So convex mirror, it is used as the rear view mirror. Okay, so rear view mirror means side mirror which is kept it in the vehicles, which why are we specifically uses this convex mirror as a rear view mirror means convex mirror, as it is a diverging mirror, it covers a wide range of field, and also as it covers the wide range of field, it gives a clear picture to the driver who is driving the vehicle, and it also helps him, it facilitates the driver to drive safely. Okay, and as it covers a wide range, and also it produces virtual and direct image and diminished image, and this convex mirror is far better than the plane mirror, because plane mirror also produces virtual and direct images, but why it is so convenient convex mirror as a rear view mirror means it covers a wide range, but that is not possible in case of a plane mirror. Okay, so that's all about this video. So today we have discussed about the image formed by the concave mirror and as well as the convex mirror, and also uses of concave mirror and convex mirror. Okay, so see you all with the new topic in the next lesson. Please do subscribe our channel to get the latest updates. Thank you, children.